Oh, Tom, I guess Wes is under there too.
How you doing?
Not bad. How are you?
I'm good.
There's Wes.
Give me 1 second, guys. I gotta see if I can make a return call real quick. I'll be right back.
Time's up. In theory, our next meeting will be in person, so this may be the last Zoom we have for a while.
Oh yeah.
And we've been talking about it for a couple of months, and even thought about having this one, but Don was more comfortable doing it over the Zoom, so we'll get one more in there. Speaking of Don,
Man, I need to get a snazzy AITP background like Mike.
I'll send it to you.
Yeah, if you got it laying around.
I posted in the share here on the.
Although it's coming through backwards.
Yours is coming backwards?
No. It just looks backwards to you. Oh wait, yours is backwards, Michael.
Yep.
Really, because on mine it looks correct.
Right, it should look backwards to you. Because you see yourself backwards.
Yeah, Wes's is forwards and yours is backwards, Michael.
Yeah, I had to deal with that too, Michael. Mine looks backwards to me, but forwards to everybody else. So,
Right. Or else when I raise my right hand, it would look like it's on my left to me. It'd be very confusing if your own video wasn't flipped backwards.
It's very confusing anyway. All right, so I need to just basically unflip it again, is what you're saying?
Yeah.
Because I know I had to flip the AITP one, the original one, originally. Let's not do that. I think we saw Mr. Flowers trying to sneak in here. Unmirror that.
Hey, good afternoon.
How are you?
Thanks, Stephen.
Good.
So now, does that one look forward or does that one look backward too?
Oop, I'm on a different screen. Hang on. It is still backwards.
Okay, good. It confirms that whatever we're trying to figure out here is consistent.
It's a mystery.
Okay, so now, like I said, to me, it reads completely backwards, but you're saying that everyone else, this looks normal.
Yep, it is forward for me now. Yep.
Weird. All right, I guess I can scooch over this way a little bit. Or should I actually stay where I'm at and recrop the image? Yeah, that might be a better idea. Who knew this was going to be so much trouble?
Well, hopefully we're at the end of the whole Zoom ordeal.
That's what I was mentioning. Hopefully we're about to start meeting in person again. All right, so still needs to be on the right side of the AITP, so let's pick it up and out. Let's not do that. So I'm going to pick that up about here. Well, that's exactly what it is now, except it's backwards. Well, let me ask you this now. Does it look like the CompTIA is on this side of me and is readable? Or does
Yes.
it look like my head is right in the middle of the IT?
Your head is on the IT. In fact, I would go as far as to say your head is full of it.
Well, we know that.
Good one, Don.
I'm very witty today. I'm on my A game.
Good for you. We need people like you. I haven't met Mr. Tom Corwin, is that right?
Yep, that's right.
Nice to meet you. I'm Stephen Flowers. I'm the VP of this group. And I was wondering, I don't think we've met before. I was just wanting to know who you are, and do you represent anybody, or are you just from the community here?
Well, I grew up in Gainesville. I worked in New York for 10 years as an iOS developer, but then I came back down here for COVID. Things were just far more lax here. Like
Yeah.
Manhattan was just kind of crazy. You just couldn't do anything. And now I'm CTO of a startup called Dive Live Dating. And two of my co-founders were Tallahassee based, but now one's in Atlanta and one's in South Florida, and I'm here in Gainesville.
What was the name of it again?
It's Dive Live Dating.
Dive. I'm sorry, I'm moving closer to the computer. I can barely hear it. All right. Dive what?
Live dating.
Ah,
So it's like dating in person, not online.
People still do that?
Well, the whole idea is to bring that back.
I hope it is.
There was just a story in the Wall Street Journal today about that. Did you happen to catch it, Tom?
No.
Yeah, it was talking about people who are re-entering the dating world and some of the adjustments they're having to make as a result of that. Very interesting. Sounds like something that you're dealing with and your customers would be too.
Yeah.
They were talking about COVID and how to handle the protocol for meeting people, and
Right.
it was fascinating.
I mean, we're playing around with different things and trying to see what works and what doesn't.
Mm-hmm. That's a startup. You're based in New York or here?
Well, I mean, like I say, my co-founders were in Tallahassee, and now one's in Atlanta and one's in South Florida, and when I'm here, I mean, we don't really have a physical presence anywhere.
Well, this is a great town for startups. It's not as popular, I don't think, as Silicon Valley or up in Massachusetts, but there's a lot of activity here. I don't know if you've had a chance to read some of the articles from the Chamber of Commerce or from the Gainesville Sun. There was just an article today about a couple of new startups that have begun here. Biotech is pretty big here, and of course, IT as well.
Yeah.
So there was just a company that was mentioned today that some researchers were working with a federal grant at the University of Florida, and they've come up with a COVID-19 test that takes 1 second. It's the fastest test available. It's still in development, but they're hoping to license it and sell it out there. So a lot of things happening.
That'd be very useful for cruise ships because right now they test every single passenger, and it's a very complex process right now.
I'll bet. It seems like cruise ships have always had some problems, haven't they, with sicknesses, because I guess it's a closed system. They've had Legionnaire's disease and all kinds of things that have been outbreaks over the years, it seems like. I got sick on a cruise about 4 years ago. AITP had a region meeting, and we did it on a cruise ship, Tom. And we went out of Miami and went down to Key West, and then we went down to Cozumel in Mexico. I did fine on the ship, but when I got to Cozumel, I got off the ship and had some local food and some local drink and some local water, and that's when I found out I was allergic to whatever bugs were down there. Had a really bad time trying to get over that, but it happens. But not on the ship itself.
Not Pancho's backyard, I hope.
It was near there. It was near there. It wasn't that place, but yeah.
Okay.
Yeah, I don't do much Caribbean cruises. I usually do the transatlantics,
Really?
where you spend 8 days out at sea.
Is that right? You go on Cunard, or how do you go usually?
Usually Royal Caribbean when they do their repositioning.
I see.
The Queen Mary 2 is really the only ocean liner in existence. Like it does nothing but cross the ocean on a regular basis, and it's a ship that's really built to deal with the North Atlantic.
Right.
To cross the ocean. These other ships really aren't designed to cross the ocean. So when you get way out there in the middle of nowhere, you start getting tossed around.
Some big waves out there, even if there aren't hurricanes, right?
Yeah, we've had to dodge a few of them.
Mhm.
We got caught in a storm in the North Atlantic, and I don't know. I thought it was fun. A lot of the passengers didn't. But it's really great to be on a huge ship like that and then just being tossed around. It's sort of like it's, Mother Nature is the final call.
No doubt about that. That would be fun. I guess the golden age was in the age of the Titanic and some of the ships that followed after that. When that was the only way to get to Europe, basically, was to sail, obviously. And it was really high-class way to go. You would meet famous people, movie stars, and CEOs. I guess you still could, but
yeah. Well, that's what Cunard on their Queen Mary 2. They really try to keep that experience.
Mm-hmm.
It's very formal, and the ship tries to be designed and just have the same feel as the old-time ocean liners.
Wes, how have you been doing lately?
I can't complain. Doing all right.
Good. I saw you online not too long ago doing some more of your edutating, excuse me, and look good.
Thank you.
Tom, how did you hear about us? Did you get an email from us, or how did you learn about us?
I have no idea.
We're not the talk of the town, I guess.
That's effective marketing right there, when they don't even know how they found you.
Might have been a meetup notification for the meetup group. It's always hard to tell.
Yeah, we have some close to 300 subscribers on our meetup group, and we've been trying to reach out to the broader community. AITP, this chapter has been in business for years. In fact, we're celebrating our 50th anniversary. And we've been meeting continuously for all that time, except for this year and the past year when we couldn't get together in person. Our local chapter, I think, has about, 60 some odd members, but they're spread out quite a bit. They're not all local. We have a lot of contacts in the IT community, and we're affiliated also with the Chamber of Commerce to a degree where we use their facilities and their communication systems to, get the word out about IT and what we're doing. Well, this live dating is intriguing to me. I'm not in the market, but I'm just wondering how that works. What you have in mind? It's not like Tinder. It's not an app then. Is that right?
No, it's an app.
Yes.
It's really more towards when you go to a venue, you check in, and then you can see who else is there.
I see.
The same orientation as you, and you can match with, if you're interested in them, that they're interested in you, you can chat with them, and it's sort of a way of meeting people at the venue you're at without having to just go up to random strangers. And when we first launched it, it kind of had the advantage of, you could keep your distance and sort of get to know someone.
That's a good idea. Avoid that awkward first moment.
Yeah, but we're trying out different things because it's kind of hard to get people to check in when they go to a venue. They're not really thinking of your app.
How are you? May I ask how you plan to monetize this startup? How are you at that?
We go through different ideas and try different things. Right now, we're really just trying to get users.
Mm-hmm. You have a website, Tom?
Yeah, it's diveapp.us. Think about that.
Dive@us?
Dive app.
Okay. I'll look that up. Maybe I'll join up just to practice in case I ever need it someday. I've been married about, a long time, but
yeah,
you never know.
Gotta have a plan B.
I think it's called Plan D for divorce, but that's not on the agenda right now. It never will be. Looks like we have a new person joining us, Mr. Holbrook, David Holbrook. Can you hear us? Zoom is very new to a lot of folks, I think.
at one of my previous companies, we used it all the time, like pre-pandemic. This was our regular video conferencing software.
For me, I keep getting bounced between Zoom and Microsoft Teams all throughout the day. And it's frustrating because the device settings don't quite stick between the two. So I'm constantly having to check which microphone I'm on or which camera I'm on. It's frustrating.
Is Teams like a real resource hog?
Not on Windows, but when you run it under like Mac OS or under Linux, it's more intensive because it's an Electron app.
Oh, I see. I was in a forum and someone said, you don't need a very powerful computer if you're just doing office stuff. And someone comments, you're not running Microsoft Teams. So I wasn't sure, kind of implied that it was a resource hog.
Yet another fancy front end to SharePoint.
Yeah. So actually, with Teams, the front end of it is basically a front end of SharePoint, but every Teams message that you send, the text messages, are actually Exchange emails. And so it's each text message and even a conversation or whatever really becomes a distribution list, it's all hidden behind the scenes, but it's just Microsoft Exchange. Yeah, I was doing an e-discovery a few months ago for some subpoenaed information and came across that like in the database where that data was stored. I was like, wait a minute, these are just emails.
It's a good thing there's not an older technology that could have handled this natively and without all that. Oh, wait, the mainframe. Yeah. It used to. Oh, we just lost Wes.
Mr. Holbrook, can you hear us, sir?
I can hear you. Can you hear me?
Yes, sir, we can now.
Oh, good. I wasn't before, but I had to change. I just loaded this. I'm running Debian, and I didn't realize how this was going to pop up or not. So at the last minute, I had to load it, and I got it to work. So.
Well, good. We're glad that you have joined us today. My name's Stephen Flowers. I'm the vice president of the local AITP chapter.
Yeah,
And several of the other folks online are members as well.
Yeah, I think I met you before, Mr. Flowers. I was attending a little class there at IT Pro, I think, and I might have your card or somebody's card. I don't know. You guys used to have some meetings there. And
yes, we did. And we're planning on starting those back up, aren't we, Don?
That's the plan. We'll have to see if July is going to be, or actually, wait, we're not doing a chapter meeting in July, right?
It's going to be September, I think.
Yep. So that should be when we bring it back in-house and have an in-person meeting again.
Well, theoretically, we're going to have a big celebration between now and then too. So I was thinking if it would be appropriate to hold it back at the Hilton on 13th. That was our venue for years and years and years, or even the other Hilton on 34th Street. I mean, we were there for a long time too. I don't know, I'm just throwing ideas out.
Wouldn't hurt to call them. Reminisce of old times.
Well, they just gave us. Anyway.
Yeah, David, I do remember you now. I think it was at one of the meetings at IT Pro TV last year sometime. And do you remember who the speaker was?
no, I just kind of passed by, said hi, and noticed you had a bunch of good-looking subs there. I never grabbed one or hung out for the meeting, but I kind of said hi, got your card, and moved on.
Yeah. Well, did you hear about us through our regular email invitation, or did you see us on Meetup?
I think I started trying to poke around your website and reach out a little bit. I might have even sent an email or left a call or something, because I'm to the point where I want to probably get a little more into IT or something. I kind of did some of that programming stuff, but I figured maybe get into some more of the IT or maybe go into something like a DevOps or something. I'm not sure, but I wanted to maybe at least get a few certs or something like that. And I started looking at some of the CompTIA stuff, but I didn't know if I really understood it, because a lot of it was just like, well, this is a display port connector, this is a C connector, this is a whatever. And I couldn't see anybody wanting to pay anybody for that. So I'm trying to figure out what's a good route to go. The Linux Foundation stuff, I mean, I'm kind of more of a Debian guy at the moment, but they're kind of maybe a little more CentOS Red Hat, which is kind of who knows where CentOS is at the moment. I mean, because they have 7 seems to have a longer EOL than than 8. And then so I'm trying to figure out where is a good place to dive in, Linux Foundation stuff or CompTIA or what. I mean, where's a good route to go? And or I don't know. I just did a little bit of the programming stuff, but I figured that that a lot of that people farm that out to India or wherever. Or there's a lot of people that are maybe more up to speed on that than I am. But I've been running a server for a while. I currently run a vhost something. It has various levels of success, and maybe I need to eventually go more into cloud things. I don't know, but even that, I kind of shied away from that when I found out that GCP wouldn't even talk to G Suite. So I mean, it just, the whole thing seemed kind of crazy to me as to does anybody know where we're going, or does anybody in the industry know where we're going, or who? I figured maybe one of you guys might know where things are going, or how to go, or where to go, or I don't know what makes sense. Where do I want to spend some effort? Where are people looking or needed?
Those are all great questions, and I think we have a couple of people with IT Pro TV, and of course Michael with great background in that, who might be able to pipe up and tell us what they think about that. I know IT Pro TV, of course, handles certification training for all kinds of different aspects of IT, and I think they really have their finger on the pulse of what's going on. So
I do know that the successor to CentOS is called Rocky OS, and I believe they just released either their first beta or their first production in the last couple of days. So
yeah, Rocky sounded interesting. It's probably one flavor I haven't ever tried.
yeah, it's supposed to be the replacement for CentOS, and if you look on our AITP-NCFL website under news, it was either today or yesterday that announcement was made, so it shouldn't be too hard to find. Or should be able to search for it too. Oh.
Yeah, and then are you guys just building your own machine, or are you doing cloud stuff? I don't know how much to embrace the cloud, and what platform are you guys using for that? What are we setting up here?
So I'm a big AWS user, so I use AWS for a lot of stuff. Google Cloud, I'm not a fan of. Microsoft Azure is actually pretty good, very robust. They've dumped a ton of money into that and developed the product quite a bit. You mentioned DevOps. The skills of deploying an app in the cloud and supporting it and maintaining it has really blurred the lines between being a sysadmin and being a developer. The two overlap in a big way. So I think you're definitely in the right place trying to learn Linux. That's kind of a required skill for a lot of people, that if you're dealing with Docker containers or Kubernetes or whatever, that's all designed and built with Linux in mind. And Microsoft has retrofit some of that over to Windows, and Apple really hasn't messed with it at all on Mac OS. So you kind of end up with Linux being the only supported thing. So if I were to start a company today and have some software development that would need to be happening, the design would certainly include a containerized application that would allow local development, but also deployment in the cloud and rapid scalability. So, that's going to combine learning Linux as the OS, a cloud platform of choice, which for me is always AWS, but, can be whatever. And then a container platform, which the most common one is Docker deployed with Kubernetes, but there's a handful of other ones that are out there. So that's all stuff that's being actively used right now. So, when you say, where are we heading? Where are we going to be 2, 4 years, 5 years from now? That's where it gets really hard to tell, because 2 years ago, Docker was riding a wave and doing great. And then, fast forward to this year where they failed to find a way to monetize the product. And now they're losing money each year. Everybody uses Docker, but nobody pays for it. So it kind of makes you wonder, like, how can they develop, how can they do R&D to create the next best thing if they don't have money as a resource? So, we'll continue to see AWS and Microsoft and, places like that have a ton of cash on hand. They're going to continue developing and creating new advancements in those spaces.
Yeah, and I would say from a startup perspective, to learn the AWS infrastructure, like inside out, because there's a lot to know about it, about the different services, and they're always coming out with new ones, and deployment procedures and setting up things to scale. I mean, the entire startup world is on AWS.
Yeah, I think my first look at it, it seemed like it was a lot of billing, and it seemed like there's a lot of resources put to billing, because like right now I run my own vhost. I pay $30 a month for it. I can deploy as many websites as I want on it. And to me at that point, it didn't seem like this AWS is really a cost-effective solution like they're claiming it to be. because it seems like you just need one guy just to manage the billing and how to do all the little microservices on and off or something. And I see it as a real good thing if there's some super duper microservice that you're going to use. I don't know what that is, but I'm sure somebody somewhere does. I don't know.
So I can't speak for the group, but for me, you know, I'm the co-founder of IT Pro TV, so I'll throw that out here. And for our company, since day one, we've had a policy of no servers in the building. And that's because, you know, we didn't want to have to deal with disaster recovery plans. And if we lose power, the site's offline and all that, you know, we wanted a fully hosted solution. Florida's a rough place to host a server. So, we deployed in AWS, and our AWS solution is, I mean, we've got a number of virtual networks and virtual machines that are up in there and running it. And we service about 400,000 customers any given day. So, you know, it's pretty heavy usage, and it's extremely cost effective for us. So for us to have that hardware infrastructure in-house would be significantly more expensive.
Yeah.
Yeah, I once applied for a job as an iOS developer at Meetup. And unfortunately, the timing was bad because right after I interviewed, they ended up laying a whole bunch of developers off. But I was talking to the CTO, and of course, Meetup started in 2001. It was sort of an idea born after September 11th. It was really the whole inspiration behind starting Meetup. And he was telling me about setting up servers and all that other stuff. I was like, you were running your own hardware? He says it was 2001. I was like, oh, right. It's just so funny that it's like, I forget that at first, you know, even Dig, you know, the company Dig, when they started, they had to, you know, buy metal and rent space in a data center and stick these things in a data center and have somebody go out there and just kind of make sure the cabinet was clean and clean with dust and make sure all the wires were still secure and all this stuff. That the nice thing about Amazon is you could configure things, and you can even using you know, different services they have there have configuration files that you commit to a repo. So it's sort of like the equivalent of, just imagine if you have a physical data center and somebody unplugs an Ethernet cable, you could go back and see who unplugged that Ethernet cable by looking in the Git repository and seeing who made that change to the configuration file. And but it's, you know, I've used a lot of virtual servers, like bare metal hardware that you know, different people were on, and then I ended up having my own server in a data center that I rented for like $100 a month. That, you know, I had root access, the entire machine was mine, and then started moving on to virtualization, like in Linode and stuff like that, because they were really cheap to run. But on AWS, I can start a micro instance and it costs me nothing, like literally nothing to run. And the API for my startup, we're running Lambda functions using API gateway, and it's, you know, a Python app that, you know, and a Lambda function is something that HTTP request is made, it gets your code, sticks it in a Lambda function, starts it up, it runs, and then after the end of the request, it shuts down. And so it can theoretically just scale as much as you want. And you have this API gateway as, you know, what's essentially listening for the HTTP request. And so, you know, and it's like thousands of a penny per gigabyte second to run this function. And I'm running it at 512 megabytes. So 2 seconds is 1 gigabyte second. Of course, the endpoints usually run a couple hundred milliseconds, except for the login and stuff where we have the hash function run, which, you know, is intentionally slow. Or creating an account, changing passwords, stuff like that. And I mean, I get like 1 million requests, or I get like 1 million gigabyte seconds free each month. I mean, it's just this, kind of ridiculously cheap thing to run on. It starts getting expensive when you really start to utilize tons and tons of resources, but it's sort of designed where it's very friendly for a small company to get on the platform and hardly spend anything a month. Storage is extraordinarily cheap, and of course, anyone familiar with the platform, I don't have to tell you, our photos are stored on S3. I have a bucket where the photos get uploaded, and then it starts a Lambda function that does all the processing to the different thumbnails, and then that goes on a different bucket, which has public access. The upload bucket is private access. And it's just, once you, like I say, learn the platform, and once you learn the platform, it becomes obvious as to how to set up these things and spin up instances and set an autoscaler. So when you get really busy, it sets up more, if you're running on a Linux machine, it can scale larger, it can scale smaller depending on the load. I mean, and I was using them back in the days when the only services they had was S3 and EC2. They just had those two services. And of course now, I can't even tell you.
Yeah, they have something like 72 services now.
Yeah, and some of them I look at it and be like, is this a joke? There's something for like managing satellites or something. It's like, what?
All right, gentlemen. Well, it is a hair after 7 o'clock, so this is a good spot for us to start. Wes, are you kicking us off today?
I can do that. Absolutely. Are you guys, everybody ready?
Yes, sir.
We got our recording going. Okay, good deal. Good deal. All right, everybody. Well, welcome to the North Central Florida AITP chapter. We appreciate everybody being here today, and it'd be great to have, well, maybe some of the viewers that are watching out there online, maybe watching this on a recording. It'd be great to have you as a member. And if you'd like to be a member, it would give you a chance to network with other like-minded technology enthusiasts such as ourselves here. Just make sure that you browse on over to AITP-NCFL.org. You can also check us out on our YouTube page. Just do a search for NCFL AITP and hit the subscribe button, and make sure you hit the little bell icon, and you'll be alerted when presentations such as the one that you're viewing right now are uploaded to YouTube. Well, thanks for everybody joining tonight. Let's go ahead and let our speaker take over here, Mr. Don Pezet, and we're going to be enjoying a presentation on hardening your default SSH settings. So Don, take it away, and thank you for joining us, and thank you for the presentation.
All right, everybody, thanks for having me. And like Wes said, I am going to be talking a bit about SSH. And, SSH is kind of a protocol that a lot of people don't think about, right? It stands for Secure Shell, and it is the default way that we log into Linux servers to manage them. And that's regardless of whether it's an on-premises server or it's something being deployed in the cloud or whatever. Linux has become kind of the standard operating system for applications, for any kind of portable application that we want to run. And that is an interesting thing because Linux, by and large, is a more secure operating system than Windows or Mac OS, that there's far less malware available in the Linux space. Not that it doesn't exist, it's just there's less of it, right? And so when many people deploy it, there's a certain assumption that this is a secure server, that everything is locked down and tightened up. But the reality is there's things we can do to make it even more secure. And you'd be surprised, the default installation is not nearly as secure as you would think. So what I want to do in this session is take a standard server that's going to be, I'm going to use an Ubuntu server because Ubuntu is the most common Linux distribution today. So I'm going to use that one and just take like a default install and show you how some of the security settings are just not set as well as they could be to secure the server. And there's actually some weaknesses that can be pretty severe. So we can't trust other people to take care of these settings for us. We always need to double check. President Reagan always said, trust but verify, right? So we can trust that the operating system vendors have our best interest in mind, but we need to verify that it's actually done that way. So that's what we're going to walk through, and we'll get a chance to see all of that tonight. So to get started, I'm going to share out a terminal. Now, terminals can be a little bit dicey. Sometimes they're hard to read, especially when dealing with like Zoom and YouTube and all that. So I'm going to share this out. And then you guys let me know, are you able to read what you're seeing?
Perfect.
Yep,
Yes.
looks good.
Okay. If any of you want me to make the font a little bigger or whatever, just let me know. But basically, this system that I'm on right now is an Ubuntu server. And so I'm running Ubuntu 20.04, which is their current long-term support model, their LTS. So if you're deploying Ubuntu Linux in a production environment, this is the one they intend you to deploy. 18.04 is still supported as well. Everything I'm going to show you tonight actually applies to really the last 4 or 5 versions of Ubuntu. If you run Debian, everything I'm showing you tonight applies to that. If you're running CentOS or RHEL or Fedora, almost everything I'm going to show you tonight applies to them as well. One big difference is that in Debian-based operating systems, the SSH service, the SSH daemon, is actually just called SSH, and that's it. But in Fedora and RHEL, they actually call it SSHD. So you just have to add one little letter, and then you're pretty much right where I am. The other thing I want to show you is this is a pretty clean install. I haven't messed with this server much, aside from installing it and making sure my hardware was detected. And also, I'm going to do a quick update, just a sudo apt update. Under RHEL or CentOS, you do a sudo DNF update. And just to show you guys that I'm fully updated. So all packages are up to date. So I did an install, I set a username and a password, and I did all of my updates, right? So my server should be fairly secure because I haven't messed with it, right? Aside from the basic things that we would normally do, creating our user account, maybe enabling SSH. And, a little bit of history there. So Secure Shell hasn't always been around. If you worked in IT back in the 1990s, Telnet was the default management protocol. You would Telnet into a server to get a console. And IBM had their own Telnet 3270 that you would use. And those protocols were designed originally to connect to mainframes. And security wasn't a concern back then. They weren't connected to the internet. And then you fast forward to today where everybody's connected to the internet, and obviously Telnet's not going to work. So if you're using Telnet on a network, it's horribly insecure. Anybody with a sniffer can capture that traffic. They can see the passwords you type. Everything's set in plain text. So Telnet's out, SSH is in. SSH encrypts everything. So I'm SSH'd into this server right now, and that means I have an encrypted tunnel between my machine and this server. And so if somebody runs a sniffer on the network and captures my traffic, they don't see it. Well, they see it, but it's encrypted. It's ciphertext. And so they can't interpret what's in there. It's completely safe. And well, it's as safe as I make it, right? When you encrypt something, there are weak algorithms and there are strong algorithms. And when you turn on SSH, you don't really know what algorithms it's using at all, right? And so that's the point I want to make tonight is when you don't know all the settings that are in place, when you don't know whether or not your security is being maintained, it's up to you to figure that out and to make sure it's configured the way that you want. So I want to show you a couple of tips that I use for hardening SSH, especially for servers that are connected to the internet, to make sure that they're protected. There are attackers on the internet that are scanning for hosts all day long, looking for systems that are running SSH because they know they can get terminal access with it. And if you set an easy password, something that's guessable, they can brute force that and potentially get in. So we need to eliminate that as a possibility and find a way to make sure that our systems are safe, secure, and that we don't have unauthorized users in there. So I'm going to show how to set up a service called fail to ban, which is a way to prevent brute forcing of passwords. I'll show you how to restrict what user accounts are allowed to access SSH. I'll walk through doing certificate-based authentication, which is way better than doing password-based authentication. When you use a certificate, you basically eliminate brute forcing altogether. I'll show how to look at what authentication protocols are enabled and how we can disable the weak ones, the ones that you'd be surprised are still enabled, and how to strengthen up encryption for the system. And then if we have enough time, I'll go into some of the weirder things like when you use encryption algorithms and you have a key exchange, they use what's called a moduli. It's a set of prime numbers to be able to generate their encryption keys. And the weaker those numbers are, the weaker your encryption is. And so I'll show you how to strengthen that if we have time. So that's all the stuff that we're going to be taking a look here. and just kind of walking through that process. If you guys have any questions along the way, if you're watching live, then just ask. If you're watching this later recorded, then throw it in the comments, and we'll get back to you and hopefully answer any question you have. So let's kick things off. When I deploy a new server, there's a handful of things that I do just kind of as my standard go-to, this is something that needs to be done. And one of those things is restricting who's allowed to access SSH. You're modifying that default configuration. And if you have a system set up like mine, that's the default, the configuration is stored in one place. If you go into /etc/SSH, and take a look in there, you'll find a file called sshd_config. Now there's SSH config, that's your SSH client. And then there's sshd config, that's the SSH server. And that's where we need to strengthen things up. Don't count on the clients to strengthen things because they always screw stuff up. Your users are the problem on your network, right? And so we want to make sure that we tighten up things on the server so that the clients don't have a choice. They have to conform or they're not allowed to connect. Now, in the old days, I used to just modify this file directly. And when I say the old days, I mean 2 years ago. So we used to go in and modify this file directly. The challenge with that is when you upgrade Linux between versions, this file can get overwritten. And so you may have taken the time to secure your settings, and then an upgrade goes and blows them away, and now you're less secure. You might not even realize it. And so on modern Linux distros, you'll have another folder named sshd_config.d. .d just means directory. And any files in that directory will be included and will actually overwrite the default configuration. So the recommendation is don't edit sshd config. Instead, create your own file inside of sshd_config.d. And when you do a new install, it's probably empty. There's probably nothing in there. And so we're going to create a new file, and that's where we're going to store our security updates and upgrades and so on. This will do two things. So one, it makes sure it doesn't get overwritten when we do an upgrade. But two, it makes it really easy for us to spot the changes that we've made. And even like for us, at the end of the episode, I can take that one file and share it with you, and you would have all the changes that I'm going to make throughout the presentation. So one place to go. So I'm going to edit a file in there, and I'm going to use sudo edit to do that. I've gotten in the habit of using sudo edit instead of su or sudo and an editor because I remote into so many different machines. I never know whether they have Vim installed or Nano or Emacs or whatever. So this one just says use whatever the default text editor is, run it as root, let me modify the file. And I want to modify /etc/SSHD_config.d/ and then I'm going to create a file just called hardened.conf. .conf is a configuration file. So those are pretty standard in Linux. And I'm calling it hardened just so I can remember what it is. You can name it whatever you want. The name actually doesn't matter. Anything in this directory will be loaded. And when I edit that, I can now start overriding the settings that are in the default config. Now, if you don't know the default config, then it's just a blank file, and that doesn't really help you, right? So if you're just getting started, you can take a look at the default config by looking at /etc/SSH/SSHD_config. And I encourage you to do this because different distros have different defaults. So a default that I'm showing you right here might not be the same in what you're running. So, here's a chance for me to go through and evaluate that. But one thing you'll notice when you look in this file is that a lot of things are commented out. There's a pound symbol. So like the port defaults to port 22. That's the standard port for SSH. It's listening on every address. And I might want to override some of that, but right now they're just set at the default. So this is really just showing me a list of what the defaults are for Ubuntu 20.04. I can see the default host keys, and already I can see there's one that's not secure, probably two. And then as we continue looking, you'll see the other defaults that are a part of it. Now, I've done this enough time that I know exactly what I want to change in here. But if you don't know, just read through it. It's actually pretty well documented and kind of tells you what each setting does, and you can get an idea of what you may or may not want to change. There's quite a bit in there. So I want to laser beam in on just the really critical things. So let me go and I'm going to edit that hardened file again. And the first thing I want to do is I want to tighten up who's allowed to use SSH. Okay. You may have multiple users on your server, multiple user accounts for various purposes. There's services that have accounts. If you install Apache, there's an Apache account. If you install Docker, there's a Docker account. You don't necessarily want all of those accounts to be able to SSH in. Most of them are service accounts, right? So they shouldn't be able to remote in at all. And we don't want attackers to try and target those, especially ones where we're not the ones to set the passwords. Maybe an automatic install did it. So I think it's really important to add this line, which is allow users, followed by a list of the users you want to allow to remote in. So I could say like D Pezet, W Brian, and whoever. You just one after the other, you list the users that you want to be able to connect in. You can do the same thing with groups. You can say allow groups, and then specify each group name if you're using them. I'm not, so I'm going to leave that off, or I'll just stick a pound symbol behind it so I don't get burned on it. And you could put your groups in here. So, maybe you have an admins group or a Docker group or something like that. And those people would now be allowed to SSH in. If somebody tried to SSH in and they weren't in this list, they would just be rejected. And no password field, just here's your username. Nope, you're out, right? And so that's an easy way to prevent people from accessing when they shouldn't. So these are simple things. Now there is one special account, and that's the root account. The root account should never be allowed to SSH in. If an attacker can target the root account, they have full access to your system, right? They can do whatever they want. So there's a special setting for that, which is permit root login. And I'm just going to set that to no. And it just says, hey, the root user is not allowed to log in via SSH. Now, if we need the root user, we can log in as ourselves. I can log in as dpezet, and then I can use sudo or su. I can elevate my privileges that way to become root after I've already SSH'd in. But I don't want somebody potentially brute forcing the root account. I don't want that remote access. Permit root login, no, is kind of a default setting for that. Now I say it's a default. It's not a default for every distro. Many distros still allow that remote connection. And so that's something you'll want to evaluate on your system. There's a few other defaults we can change. I mentioned the port number a minute ago, and we saw where that was commented out, right? Port 22. You'll find a lot of people on the internet tell you, hey, it's a good idea to change SSH to a different port number. I'll tell you, you can do it. If I wanted to, instead of 22, I want to run 2222 or 9999, right? We can pick another port, but it doesn't actually protect your system. It just makes it a little more annoying to find for an attacker. Remember, they're doing automated scans across your systems all the time, 24 hours a day, 7 days a week, automated scans. When they see a port, they'll test it for all sorts of different protocols. And SSH identifies itself, especially if you're doing certificate authentication, because it has to do the handshake to connect. So you're not really stopping anybody from hitting your system by changing that port number, but you can do it. You're better off having a firewall that's restricting who's allowed to connect on 22. That's going to make a bigger difference than changing the port number. But if you want to change it, just a line like that, port followed by whatever port number you want to use, that'll take care of it. I'm not going to bother with it just because I know it's not terribly effective. All right. The next thing is I mentioned, passwords can be a problem. And so certificate-based authentication is a way to improve that. Certificate-based authentication makes things way better. But passwords are easy, right? When somebody creates a user account, they create a password. So everybody's got passwords. It's the one way of authentication that pretty much anybody can use. So if I want to use a password, the challenge is any attacker could find my SSH server and then start trying to guess the password. They can just try over and over and over again, right? But if I turn off password authentication, when I turn that off, now they can't guess a password at all. They have to have a certificate. And certificates are incredibly complex. They're long strings. The hash of the certificate values are incredibly long. It's borderline impossible to guess them. And so that's a higher level of security. So I'll typically turn off password-based authentication and just require certificate-based authentication. Now, I'm not going to do that just yet. I'm going to go ahead and put the entry in here. I'll do a pound symbol to comment it out. But what we would do is we would say password authentication and set that to no. I'm not going to allow passwords. I need a certificate. But I don't want to turn it on just yet because I might not have it set up. If I don't have a certificate issued for me to use, then I'm going to lock myself out of the system. Now, SSH doesn't read this file until we reload SSH. So I'd be fine if I exited out and it was an active setting, but I'm going to comment it out and I'll come back and turn it on in a minute.
Well, what about fail to ban?
Yeah, we're going to turn on fail to ban in just a moment. Now, if we need passwords, right? So I want to use password authentication. Fail to ban is a great way to mitigate the brute force attacks. Okay, so if somebody gets a wrong password 3 times in 5 minutes, now it's going to block them and shut them off. Okay, and I know I mentioned like people are scanning the network all the time, and so you might wonder, what's the reality? How likely is this to happen? And the answer is actually really likely. I'll give you an example, and I'll show you a real server of mine. I'm gonna just get out of this config file real quick, or actually I'll just jump servers. So this server right here, so this is a Linux server that I run that is connected to the internet. So this one is actually connected up, exposed to the internet. Port 22 is exposed to the internet. I do have certificate-based authentication turned on it, so it doesn't use passwords, but I do have fail to ban running as well. And people routinely scan this server and trip my fail to ban alerts. So if I pull up my firewall, so I'll just do a sudo UFW status, I can see right now this line, I've got a reject line in here. So it says traffic coming from anywhere that is from 125.26.185.135. That address is blocked from connecting to my server. Now, I don't know that address. I didn't put it there. I didn't do that. Fail to ban did it for me, right? So it's an automated service that runs and it watches for failed logins, and then it takes whatever that IP address was that was connecting and creates a firewall rule to block it, right? Which immediately mitigates a brute force. So on my server, somebody will get 3 attempts and then that's it. Well, for somebody to do a brute force attack, they're usually sending hundreds of thousands of attempts, right? As many as they can send per second to try and guess that password. And so this really cuts it off right away. But there's still the chance that maybe I used a weak password. Maybe I used a password that got compromised in some breach somewhere, and so it's in a password database on the darknet. Well, now somebody who has managed to get my password that way, they could come and connect, and they're not going to get a failed login because they know the password. They try the password, it works, and they get in. Fail to ban doesn't help with that. And that's where a certificate does help. That a certificate is not something that's easily stolen to then be transmitted out like a password hash is. So it's a higher level of security. Given the choice, I'd say do both, right? And that's what I'm doing right here on this server. I've got certificate-based authentication and I have fail to ban. So there's no harm in deploying both, and they call that defense in depth, right? More than one layer in case one layer fails, another layer kicks in and protects it. So use all the tools at your disposal. And before I turn on certificate authentication, let's take a look at fail to ban, because it's actually pretty easy to get up and running. I'm surprised more people don't use fail to ban because it's incredibly useful. And I'm going to show you tonight how to use it with SSH, but you can use it with anything. You can use it with website authentication, NFS, FTP, SFTP. You can use it with pretty much any protocol that generates log messages, because that's what fail to ban does. Fail to ban watches your syslog or your systemd journal, and it just looks for the failure alerts in the journal. And if it sees ones that meet your criteria, then it creates a firewall rule to block that user. It's a really neat system, and it's completely customizable to whatever you want. With SSH, that's like a known use case. So it's already got support for that baked right in, and it's super easy to get it turned on. But if you have custom software, like you've written your own web app that uses some crazy authentication, you can just tell it the patterns, create like a regular expression that matches the log entries for your software, and fail to ban will work with that. It just needs to know what to look for. So it's kind of neat. I don't think I have fail to ban installed on this server, so I'm going to go ahead and install it real quick. I'll do sudo apt install fail to ban, and it's the number 2. Fail to ban. So the name just implies that it's converting failed logins to banned IPs, and it's banned IPs in your firewall. And it supports IP tables, firewall D, UFW. So it supports all the major Linux firewalls. But again, you can customize that. So it can create firewall rules for all sorts of different things. I've seen some advanced implementations with Cisco ASAs where the Linux server would detect the failed logins, And then it would send an API call to the Cisco ASA to create the firewall over there and block the traffic before it even got to the server. So that's beyond what I'm going to show you tonight, but those are things that are certainly possible. So yeah, I don't have it installed, so I'm just going to install it here real quick. It's all together with dependencies, a whopping 2.4 megabytes in size, so not a heck of a lot. And it's, again, like I said, really easy to get it set up. Once it's installed, if you go into /etc/fail-to-ban and take a look in there, you'll see its basic configuration, jail.conf, right there. But you'll also see several other things like action.d, fail-to-ban.d, jail.d. Each of these folders, just like we saw with sshd config.d, these are directories designed to hold our customizations. So in the old days, and again, 2 years ago, I would modify jail.conf, but now I wouldn't. Now I would put things in one of these directories or a special file that doesn't show up here called jail.local. Jail.local is designed to hold your local changes. And so we'll hit that in just a moment. But the jail.d folder is designed to hold the information about the services that you want to monitor. And then you've got filter.d, which is the tools for monitoring the logs to be able to see what a failure is. And then action.d contains the actions to take. What should I do if I detect a situation? So if I look in jail.d, there's not going to be much in there. In fact, I expect it to be empty. Apparently there's a defaults file in there. But here's where you could define each of the jails that you're going to create. And then in filter.d, this one actually has a lot of stuff, right? These are the default log messages that it's set up to watch. In Debian and Ubuntu, the default SSH server is the dropbear SSH server. And I can see that it's already got a config file written for dropbear. You can see there's a generic SSH file right here, sshd.conf. I usually use this one because this one works for dropbear, but it also works in RHEL and Fedora. It works in Debian. So like this is kind of the one go-to that works everywhere. So it's what I normally use. You'll see FTP programs, Postfix, which is email, Drupal, Dovecot, all these really common software packages, they've already defined how to monitor the logs. And so if you have something custom, you can just copy one of these. Copy one of these and modify it to match your software, and then it'll know what to look for and how to catch those events. And then if we go into action.d, that's where our actions are. So what do we do when a failure is detected? And here's where you'll see like everything that starts with firewall CMD, that's firewall D, the firewall daemon. You've got IP tables, you've got UFW, which is what Ubuntu uses, sendmail, NF tables, all these other different tools, which are ways to either block people from connecting, or in the case of sendmail, to reject emails that they send. So, you know, if they have enough failed logins, we don't want to accept email from them. And so we can block based on that. So there's a lot of different interesting things you can do inside of that. But for something standard like SSH, we don't really have to dig into the nitty gritty because we've got that default config. So to set this up, what I'm going to do is I'm going to create a new file in here called jail.local. And that's where I'm going to put my local changes. So I'll do a sudo edit jail.local. And so that file is going to be empty. I'm just now creating it. And I'm going to override some of the defaults. And oh, I should have shown you the defaults. Let me start with that. I'm going to edit the jail.config file. And here's where we'll see some of the defaults that are in place. So most of the lines are commented out because, again, it doesn't have a lot of this enabled by default. I just installed it a minute ago. You guys saw me. But the default settings are what I want to point out here, like this one, ban time 10 minutes. If somebody fails enough times, it's going to block them for 10 minutes. Now, personally, I don't think that's long enough. I think it needs to be longer, right? But how long are we banning them for? Well, just right down beneath, I can see, or sorry, not how long, but how many failures before we trip it. The default here, max retry is 5. They get 5 attempts. And if they have 5 attempts in this find time, which is 10 minutes, if they have 5 failed attempts in 10 minutes, I block them for 10 minutes. Well, maybe I want things longer, right? Maybe I want it an hour. Maybe I want it 24 hours, right? Let's go big. Hey, if somebody hits my server, it gets 3 failed logins in 10 minutes, block them for 24 hours. So we can override all of these settings over in the jail.local file. right? We don't have to comment them out here. The other file will automatically supersede this one. So, you just browse through here and figure out what matches my security policy, or what matches my regulatory compliance, what standards am I trying to hit? And then we just recreate that in our other configuration. So, kind of looking down here, you'll find all the different things you can do to identify how that's going to work. All right, so let me go back into my jail.local file. So I will edit that. And I'm going to override a few things. So first thing, I need to create a default section. So you just put that in square brackets. This is my default section. And I'm going to override the default ban time. I want to set mine to 1 hour, right? So if somebody trips my flag, I'm going to block them for an hour. And then I'll set a ban action. And the ban action is where I define what it is I'm using to block people. And I'm using UFW. And so that matches up with the UFW file that we saw in the actions folder. You would just go into the actions folder and look for whatever the name of the file is and use that here. So that file was named UFW. That's what I'm putting here. Then we get specific to whatever service it is we're protecting. I'm protecting SSHD. That's what I want to protect. All right. If I was doing a different service, again, I would put whatever that file name was. This was called sshd.conf. That's where I'm getting that name from. And then I'm really just going to put in one setting. Enabled equals true, like that. Turn it on. They're all turned off by default. This is going to turn it on. All right. And then the SSHD settings will be read from the other configuration file. So that's all we need right there. I can save that. So I'll save that file. And then we do need to restart failed to ban, which actually I don't think I ever started in the first place. So I will do a sudo systemctl. If you want it to run at boot time, you would say enable -- now fail to ban. And here's where we'll find out if it was running. And actually, it looks like mine was already running. So I'm going to have to rerun that. So I'll have to say sudo systemctl restart failed to ban. And that's just to make it read that configuration file. And so now failed to ban should be running. And we can verify that by doing sudo fail to ban -client status. And so that's going to tell me the status. And I can see I have an SSH jail right now, right? So I've got one jail created. And then if I say status SSHD and run that, here's my jail. It's currently monitoring my authentication log. That's where it knows login should occur. And it has 0 failures. Nothing is in there right now. All right. If we were to expose this server to the internet, this particular server is not exposed to the internet, so I'm not going to get scanned. But if you take like my server up here where I've already got somebody in the ban list, well, here we would actually see a little bit more on it when I say failed to ban -client status SSHD. And here I can see since the last time I rebooted this server, there have been 406 IPs banned. So, that's 406 most likely bots that scanned my server and tried to log in a few times and tripped the alert. And actually, there must have been a lot of duplicates because my total ban down here is way lower, down at 61. So there were likely some bots that tried over and over and over again and got banned more than once. So that's how that one shook out. So really active thing. And if you're using password authentication, you really need fail to ban. So, those two, like if I have to do password authentication for some reason, some requirement, some automation, then I'm going to deploy fail to ban with it. That's pretty much a requirement. But if you're using certificate-based authentication, it kind of becomes an optional component. I don't necessarily need fail to ban with certificates because when somebody connects and tries to send a password, it's just going to reject it. Passwords don't work. And so it kind of solves that problem, either one. All right, so that's fail to ban, not so hard to get up and going. Certificate-based authentication is what I was talking about last. If I want to set up certificate-based authentication, the first thing I need is a certificate. Now, some people are comfortable with that, some people aren't. Some people get really intimidated by the idea of using certificates, like I don't want to set up a CA and all that other stuff, but you don't actually have to. It's really easy to generate certificates. And I'll show you, the first thing you need to do is generate a certificate for you as the client. It's actually the client that creates the private key, not the server. So on the client side, you can check and see. I'm going to drop down to my desktop here and on my client. And in your home folder, if you just go into the .ssh folder, it's a hidden folder, and take a look in there, If you see two files, IDRSA and IDRSA.pub, then you've already got a certificate. And the IDRSA, that's your private key, and IDRSA pub, that's your public key. So you've got a certificate to use. If you don't, you're one command away from having them. All you have to do is run SSH-keygen, and it will generate new keys for you to use. All right. Now, these are my actual keys that I logged in with, so I don't want to overwrite them, but you just run SSH-keygen and it will generate your keys. And then when you come into this folder, you'll see them sitting right there. IDRSA and IDRSA pub. Now you've got certificates, right? Then you need to upload your public key to the server. Now the server is set for password authentication, so you use your password to do it, but there's actually a command for that as well. And the command is SSH-copy-ID. I want to copy my ID, my public key. And then you would tell it where you're going to copy it to. So I would say I'm going to copy it to, and it would be my username, so dpezet at, and then whatever the server name is, which I totally misspelled, server name. So it might be an IP address or a DNS name or whatever that points to the server. Now, when you connect, it's going to ask for your password because the certificate's not up there yet. And when you provide the password, it'll then copy your certificate up. And actually, I can go ahead and do that. So I'll copy that to my internal server. I mentioned it's not on the internet, so I have to use its internal IP. So I'll just say SSH copy ID dpezet at 10.0.222.51. I'll provide that, and there it goes connecting. And it skipped them because my keys already exist, right? But it would have copied them up, and now my key is on the server. And so now I can SSH in without providing a password. And you can test that real easy just by trying to connect again. So if I SSH as dpezet at 10.0.222.51, it's going to log me in, and see how it didn't prompt for a password? It used my certificate to do that. All right. So I'm now doing certificate-based authentication. Now I need to back up that certificate and store it somewhere secure, right? I've already done that. But if I lose that certificate, I could still use my password unless we turn off password authentication, right? That's where we need to make sure we protect that certificate, right? Now, since I've got my certificate in place, I can go ahead and disable password authentication. So I'll do that. I'll say sudo edit /etc/sshd_config.d/harden.conf. And now I can take away that comment on password authentication no and lock that down. All right. So now if somebody even tries a password, they'll get rejected. And then if they try passwords 3 times or 5 times or whatever I'm set to, then fail to ban will block them, and they'll end up on my firewall list too. All right, so I'm going to save that file. I'm going to come back to it in just a moment though. The next thing I want to show you all is when you connect, did you see any messages that SSH showed me what encryption algorithm it was using, or what key exchange it used, or what level of security my certificates used? No. Basically, I'm put in a position of having to have 100% trust in the folks at Canonical. Canonical created Ubuntu. And so whatever they chose as the default is what I'm using now. Is it good enough? Well, you'd think it is, but it actually isn't. And I'll show you how to test that. There's a couple of websites out there where you can test your SSH authentication. There's sshaudit.com and there's sshcheck.com. But I'll tell you personally, I don't like to use either of them. I don't want somebody outside scanning my system and identifying if I've got weak security. And I also usually have servers that aren't available to the internet, and I want to know they're secure without exposing them to the internet. So instead, there is a great script available on GitHub that you can use to scan your own servers, and you can do it internal without involving the internet. So I'm going to do that. Let me make a directory here. I'll just call it projects. And I'm going to clone a GitHub repository. So I'm going to pull this script down so that I can run it. It's a little Python script, and it's stored at github.com/ and I can post all these notes and stuff if you guys want them, but it's github.com/jtesta/ssh-audit.git. And if I clone that down, that's going to copy that script down. And if you look at the script, all it's doing is pulling up your SSH configuration and looking at what is enabled and disabled inside of SSH. What it's running is this command right here, sudo sshd dash capital T. A capital T shows you your whole SSH configuration. And when it runs, it's just a wall of text. You know, to most of us, this is not useful. But if you know what you're looking for and you hunt through here, you can find the answers to the question, what key exchange am I using? What ciphers right here? What ciphers am I using? Here's the list. And what hashing algorithms? Here's the MACs that I'm using. And somewhere in here are the key exchanges right here. Here's my key exchange algorithms. So we can find everything that's being used and so on. But the script is just looking at that, and it knows ones that have posted security advisories. So I'm going to run that, and I'll show you how it works. Again, it's just a simple script. So we're going to run it, and you don't even have to run it as root or anything. It just runs as a regular user, ssh-audit.py. And then you specify the server you want to scan. It can be a remote server if you want. If it's a different port, you'd say -p and a port number. If you're using the default port, you can just specify the IP. And since I'm running it on this server, I can just point to the loopback, 127.0.0.1. And so when I run that, whoops, it is not flagged as executable, I'm guessing. So let me do a quick chmod +x on SSH audit.py. So I'm going to make it executable real quick. And then I'll run that with a /ssh-audit.py and point that to my loopback. All right, there we go. Here are the results for a default install of Ubuntu. And you'd think I wouldn't see so much red. All the red stuff is bad, right? So my SSH server supports some of the older ECDH key exchange algorithms, which are flagged as weak. And that means that there are known ways to compromise this key exchange. And then as we look down, my host keys, I've got 3 different host keys, and I can see one of them is in the red. It's using a weak hashing algorithm. Again, this is one that has a compromise, and I need to get rid of it. So red is something that's actively been exploited. And I support them right here. I could have a client connect right now and think that they're completely safe and secure, when in reality, there's exploits available for this. Now, a yellow, that's a warning. That's not so bad, right? So this one says using a weak random number generator could reveal the key. It's possible, but man, is it really hard to take advantage of a number generator problem. That's a whole different presentation I can do another day. But yellow, you could probably ignore, but red, you can't. Red is stuff I need to change. And it keeps going like that. You know, here's all these other message authentication codes or MACs that are all flagged as being weak. They're just not strong enough. And as computers get more advanced, as quantum computing moves in, these are ones that will be quickly exploited. So fortunately, all I need to do is turn this stuff off. Half the trick is just knowing to do it, right? If we just assume that SSH is secure out of the box, we're in for a big surprise. All right. So I want to turn a lot of this stuff off. Now, for me, it really just means taking a look at whatever is in yellow and removing that from my list. Now, I showed you the lists with SSHD-T. I normally do it a slightly different way. Let me show you what I do. I basically do this. I say sudo SSHD-T, and I pipe it into grep so that I can do a regular expression search. So I'm going to search for ciphers. I just want to start with my ciphers, okay? And that's going to give me the list of ciphers that I support, right? So I can see cha-cha 20, AES 128, 192, and so on. And then I can come up here to my report and look at my ciphers and see who I need to take out, who's not okay. And so, you know, looking at my list of ciphers, oh, actually, most everything there looks good. I got greens on my ciphers, so I'm okay. Cha-cha, AES 128, so that looks good. So I don't really need to take anything out there. And then I can take a look at my MACs. All right, well, I had several MACs that showed as yellow, right? So I can take my list of MACs. I'll rerun that command, SSHD-T, pipe it into grep, and this time I'm gonna look for MACs. And here's my MACs. And if I have a MAC up here that is yellow, so like UMAC 128, I just need to take that out of the list. Here's UMAC 128. So I copy this list and paste it into a text editor and just delete any one that you want out of there, right? You just remove them. And once they're gone, you put those into your hardened.conf file. And that's going to take care of that and get those guys out of there. So let me edit. I'll do a sudo edit /etc/ssh/sshd config.d/hardened.conf. That's the file I'm editing. And I'm going to come down here and add a few more lines. And so what I've done, and just, I only have so much time, so I went ahead and did this before the show. I have taken my ciphers, MACs, and key exchange algorithms and removed the ones that had a yellow flag on them, right? So here's the list of everything that's green. These are the secure ones. These are the ones that we can trust. And so I'm basically hard coding them. I'm saying these are the ones I want, and I deleted everything else. All right. So that's going to take care of most of what the report threw at me, right? If I save and I'll restart SSH, so I'll do a sudo systemctl restart sshd, and it might get angry at me. Let's see. Nope, it's happy. And now I'm going to rerun the audit script from a moment ago. And when I rerun it, I should see a lot more green coming up. Okay. And I do a lot more green, a lot less red for all those things that we turned off. But I do still see some warnings about some of the algorithms. See, they're recommending I remove these two algorithms. Well, I've got my encryption algorithms are all green here, right? So what's it talking about? Well, it's talking about authentication, right? And if I look up here, it's tied to these host key algorithms right here. I still have a weak key that I'm using as a host key. And so I need to get that one out. That's my next one. Now, interesting thing about keys, when you install Linux, every distro does this. You need a host key. And so when you do an install, they generate the keys for you. That's nice, right? Convenient. But how do they generate the keys? Did they generate them in a way that's strong enough for you? There have actually been a few cases where they generated the keys before making the ISO images that they distributed. And that meant everybody who installed from that ISO had the same exact key. It totally blew security out of the water. So it's recommended that you never trust pre-generated keys. So I don't even care if they're all green here. I'm still going to delete those keys and regenerate them. Better safe than sorry, right? That's the way we want to treat this stuff. So I need to generate some new keys to trust, or new keys that I at least trust. If you take a look in /etc/SSH, in that folder, anything that starts with SSH_host, these are keys. And you'll see a private key and a public key. So I see I've got a DSA key, an ECDSA, ED25519, RSA, right? I've got all these different keys. I didn't make them, so I don't trust them. So I'm going to delete them. This is a kind of a pucker moment for some people where like, oh, I'm about to delete all these keys, but it's no big deal. If I were to delete all the keys and disconnect, yeah, I'd lock myself out of the system. That would be bad, right? So I'm going to delete them and then immediately regenerate new ones and put them in so I'll be in good shape. Well, unless there's a power outage or something, right? So you may choose to leave some of these in while you generate new ones and go from there. So a few different ways to do it. But I'm going to delete them. So I'll say sudo rm/etc/ssh_host*. Just anything that starts with SSH host. I'm going to blow them all away. And so now all of the, whoops, wrong folder. All the predefined keys are gone. And now I'm going to create new keys, just the ones I want. All right. Now, ED25519, that's considered the gold standard today. That's the one we want to use. And so to regenerate that key, I'm going to run this command, sudo ssh-keygen. And I mentioned that command earlier. If you just run keygen, it generates client keys for you to use. But I'm going to add a little bit more so it knows I'm generating a server key. I'm doing -q for quiet output. I don't need all the text it's going to display. -n is telling what passphrase I want to use. I don't need a password on this. It's a server key. So I'm just setting it quote, quote. So it's blank. It's not going to have one. And that's important because the service needs to be able to load it. If it has a password, I've got to provide that password every time I restart the service. So that's going to create an outage sooner or later. -t is the type. I'm doing an ED25519. And then -f is the file I'm creating. I'm creating /etc/ssh/host_ed25519_key. This is the private key that I'm generating, and it'll generate the public key as well. All right. So I'm going to run that. That's going to regenerate that key. And then I'm going to run another command. I deleted the RSA key. Now, RSA keys are considered the standard. ED25519, that's the gold standard, like the best we can have. but RSA gives us the best compatibility. More people support RSA certificates than anything else. So we want to have it. But the problem with the default one is it's just weak. They build it with a 2000-bit or 2048-bit key. There we go. That's what I'm trying to say. And 2048 used to be a really big number, but today it's not as big as it used to be. So I'm going to regenerate that by running that same command, but this time for the type, I'm going to put RSA, and for the bit length, I'm going to do a 4096. I'm going to double the bit length of this key. That's going to make it a lot more secure, right? It's going to, it's not quite exponential. It doesn't double it. It just significantly, it more than doubles the difficulty of compromising it. So I'm going to run that, and that's going to regenerate that key as well. All right. Now, if I take a look back in the SSH folder, I can see that it generated the public key and the private key for each of those. I'm not going to regenerate any of the DSAs because those are all bad, right? Those are all weak. The EC DSA, which used to be great, that one got broken last year, so that one's gone too. I'm just going to do these two, the gold standard and the standard. So these two are enough for me. Now, once they're in place, I could stop here, but SSH is still expecting those other certificates to appear, and they're gone right now, so I'm secure. But what if 3 months from now, another sysadmin generates one of those keys for another reason? Well, it would immediately become active, and I don't want that to happen. So I'm going to hard code it so that those are the only two keys that I use. So I'm going to go back to editing that harden.conf file, and I'm going to add a few more lines here to the end. I'm going to add host key. So I'm telling it what host key I'm going to use. And then I'm pointing to /etc/ssh_host_RSA_key. So that's the RSA one. And then I'll do the same thing for the ed 25519. I'll punch that one in, and that one's there too. And now, if anything else is loaded, we're going to reject that, and I'll double down on that by modifying my host key algorithm list. So I'm going to paste that in here. And this came from the sshd-t command output. Here are all the key algorithms that were supported. And basically, I've just pared it down so that we've got the ed 25519 and the RSA one here in the list. Okay, so that's going to help tighten that up and make sure that I only support that. All right, so I'll save that file. I'm going to restart SSH one more time. So systemctl restart sshd. So it's going to restart, and then I'm going to run my SSH audit script again on my system. And so when I run it, that's what I want to see. Now I've got all green, weak protocols that have known exploits or vulnerabilities, ones that are on the cusp of being broken by quantum computers. Those are all gone. And what's left is the highest security that I can get on this system. I've maintained compatibility by keeping things like the RSA keys. If I was super secure, I'd get rid of those too and just do ed 25519. But I've maintained compatibility, functionality, and now I've got a significantly stronger server. All right. So everything I've shown you to this point is stuff that I do on every Linux server that I work on, whether it's Red Hat, Debian, Ubuntu, Arch Linux, you name it. These are the steps that I follow to make sure that this is as secure as possible, that I've done my due diligence, right? I've done my work to protect this so that I can have the management interface active and be able to access it. There is one more thing that I normally do, and I know I don't have much time left. So I mentioned moduli earlier. Encryption, the whole idea of encryption, if you ever dig really deep into how encryption works, it really all boils down to prime numbers. They need really, really, really long prime numbers to be able to generate random keys and high encryption security and do key exchanges and all that. It's all built around these prime numbers. But not just any prime number will do. They need what's called a Sophie Germain prime number. So prime numbers are already weird. Sophie Germain are even weirder. In a Sophie Germain prime, it means if we take a prime number and multiply it by 2 and then add 1, is it still a prime number? And if so, then it's a Sophie Germain. Now, don't memorize that. That's not going to benefit you ever. So the key thing, though, is we need special prime numbers. And those prime numbers come from our moduli. Now, most people won't mess with this, but it's a weakness in your security that some people don't know about. If we take a look back in, whoops, I'm not in the right file, there we go. Back in /etc/SSH, there was a file in there called moduli. And if you ever look at it, so I'll open it up. Well, I'm not gonna edit it. Let me just do like less moduli. It's a weird file. It's got a bunch of hexadecimal numbers. All right, these are hexadecimal. If we were to convert them to our regular base 10 numbers, they'd be insanely long numbers. Well, not too insanely long. You kind of see how long they are right here. This is a 2047-bit number, right? So 2047-bit, that's a lot. But I just mentioned a few moments ago when I was canning those RSA certificates that it used to be a lot. Now it's not quite enough, right? If you keep scrolling down, you'll see where there's a ton of these numbers. And then they go up to 3071. And then it'll jump up to something else as we go down there, 4095, all the way to the end of the file. If we fast forward, it would have been faster to do an end of line, but you'll see 8,000, there we go, 8,191. Well, if we've got really strong numbers, why would we keep the weak ones? And who generated this file anyway? Is this unique on my machine? I'll tell you one thing right now, it's not. This is the file used by many, many machines. So we might choose to, one, at a minimum, delete the lower end numbers out of here, right? Or two, if we're really hardcore, generate our own moduli. Now, I'm not going to generate my own moduli right now because on an i7, it actually takes about 7 hours to do it. It's a very mathematically complex, computational heavy process. So it takes about 7 hours to do, right? And I don't want this to be a 7-hour talk. But just deleting the low end stuff is really easy. In fact, there's a simple awk command that you can use. We're going to go old school Unix for a little while, where we can come through and say, here, I'll do it this way. Let me get into my home directory. I'm going to copy that moduli file. I'm going to copy it into my home directory. So I'll just copy it right here. So now I've got that moduli file, and I'm going to run awk. And awk is a text string editor. It can do search and replace and things like that. And I'm going to look for the 5th column, and I'm trying to identify lines where the 5th column is a number greater than or equal to 4,095. So basically show me everything strong, as strong or stronger than 4,095. I don't want anything weaker, just show me what's stronger. And I'm going to output that into a separate file. And so when I run that, now I've got 2 files. I've got the original moduli that was 535K in size, and I've got my new moduli that's only 439K in size. It shrunk because I got rid of the weak stuff from it. If I edit that, so I'll just open up moduli.4096. I can see right from the first line, it starts with 4,095. The weak stuff is gone. And so if I know that I haven't screwed this file up, which I haven't changed it, whoops, I'm about to screw it up. So let me get out of that. If I know it's safe, now I can copy it over and replace my existing moduli. So that's what I'm going to do. I'm going to copy that over. And so now the next time I do a key exchange and SSH reaches out for that giant prime number, it's going to get one that's over 4,095 or 4,094 bits in key length, so in just digit length. So that'll give it a nice strong one. If I wanted to regenerate it, I would use that SSH keygen command again. So SSH keygen can actually generate moduli for you. And I'll stick it kind of in the notes that go along with this to show how you could generate your own. The first pass, just generating the numbers, really takes about 5 minutes. But then actually doing the screen to find out what you want on a weak system can take about 7 hours. On a strong system, it can take 45 minutes or so. So it can be faster on some, but it's a long process. So just be ready for that. But with that, my server is strong enough to pass all the SSH tests that are out there. I know I pruned off all the little stuff, and I did a surprising amount of changes for something that should have been secure by default. It's SSH. It's secure. It stands for secure shell, right? I shouldn't have to do anything, but it turns out I actually had to do quite a bit. All right, so that's my presentation on hardening SSH. Let me open up the floor for any questions you guys might have.
Do you ever worry about there's layers of protocols. Do you need 1, 2? There might be a 3. I don't know. On SSH.
So there's 2 versions: SSH version 1 and version 2. SSH version 1 is compromised, so you should only use SSH version 2. Most Linux distros like Ubuntu don't even support version 1 anymore. So it's not something we really have to worry about, but you can check the documentation of your distro to see whether or not it supports it. If it does, that one actually shows up in, let me see if I can find it real quick, inside of our config file. Whoops, not that one. I want to do a sudo edit. Let me see if we can find it here. That's not it. All right, well, I don't see the entry in here, so it might not be there by default, but I believe it's just version followed by 1, or version followed by 2, or version followed by 1 space 2. So 1 space 2 would support both versions, and then just 2 would say, I only want to support version 2, which is exactly what you want. You do not want to support version 1.
Don, why do the distributors not have something in there during the process of install that says, if you know you need backward compatible, go ahead and install these more or these less secure protocols. If you don't think you need them, let's just stick with the more secure.
So two reasons. One is they are trying to provide maximum compatibility. So I just did a bunch of work on my server, and I've been connecting with my command line SSH client. But what if I decide to switch over and use PuTTY as my SSH client, or something else? It may not support all these algorithms, and now I can't connect, because it only supports something older or whatever. So they are trying to be compatible. But the second reason is most of the distros are created by people who are not thinking about security first. They're thinking about, I've got all these bugs to fix, I've got these features I want to roll out. Security is not first and foremost in their mind. And so you end up with deployments like this where it's not hard to tighten that security, but just nobody's focused on it.
A follow-up question. I didn't see anything in the presentation that couldn't be nicely scripted into an aftermarket package. Have you thought about maybe just, adding some error checking around the core stuff and marketing of that as a product?
You could. What I would do, and what I've done in the past, is write an Ansible package. If you've ever worked with Ansible, it lets you write portable configurations. So you could define this as an Ansible package, and then you could deploy it to 1 server, 1,000 servers. And anytime you deploy a new one, it just automatically hits and makes sure they're all configured the same way. So that type of configuration management, most of the distros decide, hey, that's up to you. If you want that, do your configuration and go. But yeah, there likely is a market for that. There's programmers, developers that are out there that have been thrust into the DevOps role, where they're great developers, but they haven't been trained on security. And they would really thrive from, hey, just give me a default config that gives me security. That's one of the real selling points of Docker or containers in general, is containers are so stripped down. Even if you do bad security and somebody hacks into it, there's only so much they can do inside of the container. Versus a full distro, once they get into a full install of Linux, it's sky's the limit. They can do whatever they want. Any other questions?
I gotta ask, in those module files, why are the bit links 1 bit shorter? Why is it 4095?
They start with 0.
Oh, okay.
Yeah, that's why it's off. So technically 0 is a bit, and so it would be 4096. Yeah, it's 1 off, which is a little weird, but that's computers.
It's one of those 2 errors, 2 most common errors.
What is it? 10
naming things, cache invalidation, and off by 1 errors are the
Yep.
2 most common errors.
I always like the shirt. I think Wes has this shirt that says, like, there's 10 types of people that understand binary, those that do and those that don't.
Yes.
It's the 1 0 is, or 0 1. Oh shoot, now I screwed it up.
That's all right.
1 0.
Yeah, it's 1 0, else the shirt really wouldn't make sense. I had another question. You had that one command, which I was actually unfamiliar with, that allowed you to you generated your key, then that one command that uploaded your public version of the key to the server.
Sure.
How did that authenticate?
So it did password authentication. So SSH copy ID is actually a script. It's in every distro these days. It looks like a command. It's part of the open SSH package, so that's why they all have it. But when you run it, it's really just calling SSH in the background. And so it's doing SSH with password authentication. So that's why I got prompted. Well, I didn't get prompted because my
You
certificate
didn't get prompted. That's why I'm asking.
I didn't get prompted because my certificate was already there. Yep. Sorry about that.
Okay, I get it. I get it.
Normally it would prompt.
It
And
actually
then-
used certificate authentication for you, but normally you wouldn't have that set up when you run that command.
Correct.
You
Yep.
would have gotten prompted.
So
Got it.
it would prompt for the password. And then once you do the password authentication, it does an SFTP file transfer to deposit the key in your home directory. So that's what it does.
Right. And so all this hardening you showed us, that would apply over to SFTP too, correct?
Absolutely. Yep. Anything that relies on SSH. And then, if you have protocols, I do this a lot where if I have a protocol or a software that just doesn't have good security, well, I'll force it over an SSH tunnel. Let SSH give me the security, and then the software can run over that tunnel. So, it's a good replacement for that.
So another question, how do I know what protocol my client is using to connect to it currently?
So different clients report that different ways.
Yeah.
And usually you can see it inside of your configuration. So like I threw out the example of PuTTY, you can see that, but in Linux, it's actually configured. Let me see if I can find it real quick. It's in your client configuration. So when I was going into /etc and /etc/SSH, I kept going into SSHD_config, but there's also SSH_config. And that's the one that is the client configuration. And so in there is where you can see what it's using. And actually here, I'm searching this, but I stopped sharing my screen. So let me bring my screen back up and I will show you. As soon as I remember how to share my screen, I did it once tonight. Here we go. I can do all this SSH stuff, but figuring out sharing my screen, that's more advanced. All right, so inside of /etc/SSH, I kept going into SSHD config and SSHD config.d, but you'll also see SSH config and SSH config.d. That's the default configuration for the SSH client for the whole machine. You might also have another of those files in your home directory in the .ssh folder. That's where you would override it on an individual user. But to set it for the machine, you could either modify this file or create a file in the .d directory. And if we take a look at that, which was SSH config, in here, this is the client. And so as I scroll down in here, you'll find the ciphers that it defaults to and the MACs that it defaults to. They're all right there. So you can hard set your client. But the thing with that is, let's say I buckled mine down and I said, I just want to use ed25519. That's the identity file. So I'm going to get rid of all these other ones. And so now I know I'm using it secure. I would have been able to connect up and have a really secure connection for me. But other users that are connecting to the system would still be connected with whatever they wanted. And that might be something very weak. And so that's why I say we should always focus on security on the server, because the clients, it's just not reliable.
Right. The reason why I was asking about the client is if I SSH into somebody else's server, I don't want to be subjected to a downgrade attack. So I was wondering how I can harden my client not to downgrade to those ciphers.
Yep. And this is how you would do it. If you just chose not to support weaker protocols, then you wouldn't, the initial handshake would happen. And when you couldn't handshake on a protocol, you would drop connection.
Right.
Yep.
Now, this is a little bit out of scope, but are there any other services? You mentioned Telnet, which I know is not enabled by default anymore. I don't think it's installed. But are there any other services when you first configure a machine that you go through, make sure they're off or gone?
Yeah, there's a lot of them are off by default. SSH is the one kind of exception. So a lot of distros have SSH turned on by default. And so that's why I focus on it, right? It's pretty rare that a distro has other stuff enabled. You can look at your default firewall configuration or do a SS-NATP, and that'll show you any ports you're listening on. You can see what's going on. Typically, you only see SSH in the list on a default install. right? But there are other things that might be enabled. Syslog or rsyslog is a great example. It transmits all of your log files in plain text. So, that's one that does not have security built in. If you've got it turned on, you should be flowing that over an SSH tunnel or using something else to secure that. Protocols like Snmp, the Simple Network Management Protocol, that used to be awesome back in the 90s. You can see all this information about your servers, but even Snmp version 3 has security concerns around it. That's another one that people can try and brute force your community names and passwords. And so it can be protected with fail to ban. It can be tunneled over SSH, just the ways that you can kind of secure it. But again, most of those are going to be off by default on your systems.
Don, just in general with working with you for, a number of years now, I know how you do not trust self-signed SSH certificates. I know you delete them. I guess my question is, just thinking in perspective, because the only thing I have really to relate to it is, doing like an internal CA where you're doing internal certificate management, let's say in a Windows environment. On a larger scale, how would you manage or tackle SSA key key management?
Yeah.
That makes sense.
So what I just did is great for like a one-off thing, but let's say that I work for a company and I just generated my own key and they fire me tomorrow. Well, my key is still valid, right? They would have to go and disable my user account on the server to disable that key from authenticating. Well, if there's 1,000 servers, that's a lot of places to go to disable that key. Or I might have a different key on every single one of them. That'd be a nightmare, right? So in those situations, you want to set up a centralized certificate authority, a CA. And when you have a CA in place, you can generate certificates for people on their behalf, right? So I can, anytime I hire somebody new, I can generate a certificate for them and give it to them. And I can say, here's your public and private key. Here you go, right? Now they've got their key. And since it was generated from my CA, if I ever terminate that employee or if I ever think that key gets compromised, I can go to the CA and I can revoke the certificate. So that gives me a centralized place to do it. So that's centralized key management. If you're deploying in the cloud, AWS, Azure, Google Cloud, they all have key management as a service. So you can do that if you trust them, or you can stand up your own Linux server. Any Linux server can be a CA. Well, any Windows server can be a CA, I think, as well. But definitely on Linux, it's easy to bring one up. And now you're kind of setting up what's trusted for your organization.
Oh, okay. So you do bring it into like the whole larger scheme of PKI and manage it through basic certificate lifecycle that way.
Yep.
Okay. That's where I had kind of the disconnect because I can relate it to Windows, but I've never stood up a Linux CA.
Wes mentioned PKI, so that's public key infrastructure, and a certificate is one part. A CA, a central certificate authority, is one part. There will be sub CAs that kind of are intermediaries that fall into it. There's the revocation list, that's one part. And there's that lookup server whose name I can never remember. There's another component.
OCSP?
Yes. Yep.
Is it the online certificate status protocol server?
Yep. And that's what any server can check in with to see if a certificate is valid. Thank you for remembering that. So that's all part of what makes up a PKI, a public key infrastructure. Now, for a small business, that's a lot to set up. It's a lot of moving pieces, right? So enterprises are going to have that. But small and medium businesses, if you're looking to do it, I would encourage you to use one of the cloud servers. Just let it be managed. Yep.
So you could do this let's just throw a technology out there like Azure Key Vault. You could manage this from something like that.
Yep, absolutely. Any other questions?
Yep, I was just about to say the same thing. All right. Well, if there's no other questions, we're going to go ahead and bring this one to a close. However, we do want to remind you, those of you that maybe are catching this on a replay, it's always great to have new members, and we're always looking forward to networking with additional people, again, that are technology enthusiasts, much like the people that are in this room. Just remember, browse on over to AITP-NCFL.org, and likewise, check us out on YouTube as well. Remember to subscribe. Again, hit the little bell button so that you can be aware of anytime we upload new videos. But as for everybody here, Don, thank you so much for your presentation. We appreciate having you here, and we appreciate having everybody else here. So check out our website, and you can see the upcoming events and all the presentation and the different meetings that we're going to have coming up in the future.
Thanks, everybody. Hopefully I wasn't too boring, and look forward to seeing everybody in the next chapter meeting.
All
All
right.
right. Thanks a lot.
Take care, everybody. Thank you for joining.
Bye.